In this video, we are going to explain how to visualize differential forms on R2 and R3. So the first part is understanding how to visualize differential one forms, because everything else is sort of based on this. So this is based on the procedure for visualizing elements of the dual space that we discussed at the beginning of the class. So if I have a differential one form, let's say on R2, well, maybe I'll just talk about this in general. So n is either 2 or 3. Then I visualize alpha at a point in TPRN by drawing alpha p inverse of n, where n is any integer, so 0, plus or minus 1, plus or minus 2, etc. So what this means is, so this is my d by dx, d by dy. This is a drawing of TPR2 for some p. So say I want to visualize the one form dx. Then I should draw the preimage of 0. Oh, sorry, I'm thinking of a completely different example. Draw the preimage of 0, which is the line, the y-axis, then the preimage of 1, the preimage of 2, etc. And these are going to be, this is going to be how I visualize dx. And so what happens is that when I want to compute like dx applied to this vector, it will just be the level set that the vector lands on. So this is a vector v, then dx of v is the level set that v ends on. So here it will be 2. And more generally, if I want to do like dx plus dy, well, now I have to, so this is my d by dx, this is my d by dy, picture of TPR2 again. I want to draw the level sets of the function x plus y, which here look like this. Okay, so there are a couple of different ways I can understand. Oh, and I guess I should talk about R3 before I talk about varying the point in R2. So on R3, I now have dx, for example, any one form at a point is now a linear functional from a 3-dimensional space to a 1-dimensional space, right? From TPR3 to R. So its level sets will be 2-dimensional. So I'm going to draw this on this page below because when I upload this to Canvas, it will cut the page off. So here, if I have TPR3 and I want to draw the level sets of dx, well, the zy plane is certainly 1. This is the n equals 0 level set. And then also the plane x equals 1 is also 1. This is the n equals 1 level set. And I can just keep going. So draw all of these planes parallel to the xy plane for various values of n. And we'll do one more example, quick example. Dx plus dy plus dz. If I am to draw, again, so these are the d by dx, d by dy, d by dz coordinates, etc. as before. Now I'll just draw some positive level sets. So, and I'll just draw their intersection with the first octant because it's really hard to draw slanted planes going on to eternity, sort of general slanted planes. Okay, so there would be like the n equals 1 level set, here would be the n equals 2, etc. No, I already used blue. Okay, and then here would be like n equals 3. So then the next question is, how do I deal with points deal with the point varying? So how do I visualize alpha when p can be any point in Rn? So basically what we've done so far has just been essentially like a fancier version. I mean, basically the exact same thing that we did for dual spaces at the beginning of the class. But now I want to understand what happens when p varies. So there's two methods. So the first method is draw a small picture as for TPN, or TPRN at several values of p. So as an example, it's not really that interesting to do this when your vector field is constant, but let's just do this for dx as a one form on R2. So what happens now I'm drawing R2. I'm going to draw my little picture for dx, this little picture, and I'm going to draw it at a bunch of different places. So I'll draw it at the tangent space to 0, 0, tangent space to 0, 1, 0, -1. I'll just draw it, wherever I want. And your book also suggests that you put a little arrow indicating which direction the level sets are increasing. So I'll put a little arrow pointing to the right everywhere because I know that the function x increases to the right. Another sort of maybe more interesting example is the one form xdx plus dy. So this one, if I draw it on R2, if I draw all the, if I assume x is 0, then I'm just thinking about the one form dy. So I can draw all of those, a bunch of little indicators of the one form at different points along the y-axis. But now as x increases, I better have, so if x equals 1, I better have a picture like this one everywhere along the line x equals 1. So I'll draw those. And when x equals -1, I should sort of have this opposite picture. And then as x gets larger or more negative and y, the line should get steeper and steeper. Okay, so and then if I'm drawing, if I want to draw the same example, xdx plus dy as a one form in R3, I should be drawing little planes at every point. So basically just doing the same drawing. Need a little more space than this, but with a little plane that also extends into the z direction, because the kernel, right, so the level sets of this, if I change z, I'm not changing the value of the function. So there should be like a little stack of planes at a bunch of different points that I'm interested in understanding what is going on at the tangent spaces to those points. But then also, I could have one up here. Okay. So there's a second way, and in this method can kind of give you a little more information because, with this first method, I'm only seeing some set of points. So in this method, I want to draw curves in R2 or surfaces in R3 connecting all the alpha p inverse of 0. So I'm just taking the 0 level set and connecting it. So for dx, for example, that's just this one level set in the middle. And basically, I just connect the dots. So what I'll end up getting is all these vertical lines again. But for this example, I'll draw my, my 0 in the middle. And what I should end up doing is connecting them all. So so maybe my visualization will look something like this. And I can keep drawing these curves forever. So this maybe helps me see a little bit better what's actually going on. And then here I need to also include the z direction, so I'll sort of have curves that look kind of like surfaces that look like this. And they'll be filling up the whole space. Maybe I'll draw one more up here. Something like that. So the one drawback of this method is that it's not always actually possible. This is not always possible in R3. And on your worksheet on September 24th, you're going to consider a specific one form dz minus y dx, for which it's not possible to do this anywhere, actually. Okay, so that's it for one forms, visualizing one forms in R2 and R3.